Okay, I'd like to show you one of the demonstrations that Ralph Beyerlein describes in his first chapter on waves, because I realized that it might not be obvious from reading it what he's talking about. So this device, which you can show waves, is composed of what he calls a sort of skeleton, long, basically wires, stiff wires, which are laid out front to back in this position, and then they're connected by a thin wire running along the middle. Now, as a result of this connection between these long wires or rods, they like to lie in the same direction. So if you pull one up, the other one tends to get pulled up too. And so what I'll do now is give one a quick pull up, and you can see that it generates a wave which propagates down the collection of wires. So let me just run through that again, just to point out the main feature, that the shape of this basically goes undisturbed. And then, of course, when it hits the end, stuff happens which we'll try to ignore. You really want to focus on the initial launch. So if I start with something going down, this goes down. And you can make more complicated patterns too. All right. So I have another one next to it, and this is the same thing, except the rods are shorter, and it turns out as a result, the waves move faster along it. So there are just a couple of phenomena that I'd like to illustrate. So one was just the existence of waves. A second is the property of superposition, that waves can pass through each other without sort of colliding. They just overlap where they coexist, but then they pass through each other as if the other one hadn't been there. So first let me do the experiment that Beyerlein describes, where we send in sort of two waves that are both upward pulses. Let me just get this thing stationary again. So two upward pulses will be, and you can see how they pass through each other. But more dramatic is one upward pulse and one downward pulse. So let's see if I can do that. And again, so this illustrates the principle of superposition. So there are a couple of interesting things that happen at the, sort of ends here, which I've asked you to try not to focus on initially. So let me take a second and hook up these two different devices. Okay, so now we're in position to have two of these together. So when I lift one of these rods, it actually tries to lift the rod next to it. So this is like a wave moving from one medium into another. What we'll see happens is we'll launch a wave. When it reaches the other end, part of it propagates into the other medium and part of it reflects. Let's take one more look at that. Because what I'd like you to tell me, if you can, or tell yourself, is whether the upward moving pulse gets reflected as an upward pulse or a downward pulse. And likewise, does the upward pulse go through as an upward pulse or a downward pulse? You can probably see better than I from your angle. And let's try it from the other direction. So I will send in an upward pulse from this side, and we'll see whether it comes back upward and whether it goes through upward. That might have been harder to tell. I will give it one more run after things have settled down for a second. Okay, here's their best shot. So we'll discuss this in the lecture notes also. But one thing I'd like to do is disconnect them for a moment and ask you to take a look at what happens to the waves that bounce off the end that I'd asked you to try to put out of your mind before. There are two situations we're going to consider. One will be where I hold this end completely still, clamp it still. I'll put it in an upward pulse, and let's see what happens. I think it's supposed to come back backwards. It's supposed to come back inverted, upside down. And let me try it once more, see if we get a better shot. Okay, I think that was pretty clear, coming back inverted. On the contrary, if you let the other end go free, just let it hang out, We'll try to launch this on this wave machine, and we'll send an upward pulse in, and this comes back, it turns out, as an upward pulse also. One of the things that I'm going to be asking you to do is playing with a little Java applet that was written by the University of Colorado Physics Education Research Group to demonstrate this same phenomenon. But I think it's nice to see that it really happens. It's not just in computer simulations, though the computer simulations have the advantage of, well, not having to worry about fumble fingers